Alright, let's take another look today at solving equations with radicals. Today our lesson is new and improved, now with more radicals. Yeah, that's right. What happens if there's more than one square root? And we'll talk about cube roots and things of that nature. We're not going to look at any like that though today. Our steps have changed ever so slightly. You can see that isolate the radical became isolate a radical, and the reason is we have more than one, so picking one becomes important. Then we're going to raise both sides of the equation to a power that will cancel a radical. It won't cancel both of them. It's very important to realize that we may end up with a binomial that we are squaring, and if we square a binomial, that means foiling. And if we're foiling, unless we happen to have a conjugate working for us, which we won't have because we're squaring, our radicals are not going to cancel out, which adds in this next step, which is repeat. It's just an exercise in patience. All right, we're going to go back up here, isolate a radical. At this point in time, hopefully we have made it the radical. Okay, every time we square both sides or raise both sides to the equation to a power that will cancel a radical, we want to make sure that we are canceling out one of our radicals. We're then going to solve and we're going to check. Why are we going to check? Remember that we have the possibility of extraneous solutions, extra solutions that get created when we multiply both sides of an equation by a variable. Our first example today is the square root of x plus 6 equals 5 minus the square root of x plus 1. And if we square both sides, we should be able to get some things to happen. First of all, the square root of x plus 6 will become just an x plus 6. The other side of this becomes something that we need to FOIL out. So let's take the time to kind of look that over a little bit and make sure we understand that when we square a binomial, that means we have to FOIL. That will give us a 25. It'll give us minus 5 square roots of x plus 1, another minus 5 square roots of x plus 1, and a plus in x plus 1. And if we simplify that side down a little bit more, we'll get a 26 plus an x minus 10 square roots of x plus 1, all equal to our x plus 6. Well, we've done it. We've eliminated one of our radicals. Now we're going to go back and repeat the steps again. We're just going to isolate our radical again. We'll subtract our x's. We'll subtract 26 from both sides. We'll get a negative 20 equals a negative 10 square roots of x plus 1. Divide both sides by a negative 10. That gives me a positive value, which is exciting to me. I don't like square roots that are equal to negative values. They don't work out too well in the end. And we're going to square that. If we square both sides of that, let's change the color so we can see the step change. If we square both sides of that, we will get a 4 equals an x plus a 1, and we'll find out that x equals 3. All right, x equals 3. And of course we want to check that. Let's go check that. We'll plug the 3 in, so we'll have a square root of 3 plus 6 equals a 5 minus the square root of 3 plus 1, or a square root of 9 equals 5 minus the square root of 4, or a 3 equals a 5 minus a 2, and that is correct. So it does work. Let's take a look at one more example today. We're going to start by squaring both sides of this guy. And when we do that, remember we are going to end up with a binomial on this other side that is getting squared or multiplied by itself, which means foiling. Not a big deal. We just got to make sure we take care of those things carefully. We get a 9, we get two different minus 3x's, which is going to give us a minus a 6x, and we get a plus a square root of a square root, or I'm sorry, a square root times a square root, which will give us a regular old x. Do some subtracting from both sides, and we should end up with a negative 24. Pardon me, I missed our square root in there. Equals a negative 6 square roots of x. We'll divide both sides by our negative 6. We'll get a 4 equals a square root of x. And if we square both sides, we find out that x is 16. However, if we go and check, perhaps my voice kind of gave that away, but if we go and check that, we'll take our 16 minus our 15, set that equal to our 3 minus our square root of 16. We're going to get a square root of 1 equals a 3 minus a 4. And if we do that, we'll get a 1 equals a negative 1, and that is not true. And since that is not true, there is no solution available to this problem. So once again, our steps, 4 steps, I should scratch that, that became 5 steps today. Isolate a radical, raise both steps, both sides of the equation to a power that will cancel the radical, and then repeat so that you get rid of both radicals. Solve and always check your answers. This should help you solve any radical equations that have more than one radical in them. Keep in mind, if you were doing something that had a cube or a fourth power, you would be raising a side to a fourth power. A polynomial to a fourth power would get a little bit ugly, so we'll probably steer away from those in our homework today.